NASA just released a huge warning about geomagnetic storms that could completely disrupt the electric grid. You might have probably heard very little about one of the most ridiculous things that could potentially be a huge threat to the modern power and communication systems. We're talking about solar activity, which could wipe out unprepared grids from millions of miles away. But this threat was never new, as it always existed even in the ancient times. So why is NASA worried about this, and how dangerous can these geomagnetic storms be? Well, that's exactly what we find out in this video. So stick till the end to know how these storms can totally take our planet to the dark ages for weeks or maybe even months. For starters, the sun's magnetic field undergoes a cycle approximately every 11 years. According to NASA, the sun transitions from relatively calm to active and stormy, and then quiet all over again. But when it gets stormy, the impact can be highly destructive. The current transition stage of the sun is much more active than what scientists had already predicted in 2020. The sun is freckled with sunspots, and its magnetic poles tend to reverse. The monthly average number for the number of sunspots at this stage in the solar cycle far exceeds the number forecasted by scientists. According to the Space Weather Prediction Center in July, the sunspot number was about 91.4, whereas the predicted value was about 42.8, so you can clearly see a huge difference. This means that the sun was more active than what scientists expected at this stage in the cycle, and this activity is only going to increase as we near the solar maximum in 2025. Now, for those of you who don't know, solar maximum is a period in the sunspot cycle where solar activity is the highest and sunspots are the most abundant. NASA also suggested that with increased activity comes an increase in space weather events, including solar flares and solar eruptions, which can cause huge impacts on electric power grids, radio communications, and navigation signals. It can also be a threat to spacecraft and astronauts. Way back in 1859, astronomer Richard Carrington observed a massive solar flare vented by the sun. The resulting electrified gas and subatomic particles ended up damaging several telegraph communication networks all over the world. Some machines were even completely destroyed. Given how sensitive our communication systems are today, a coronal mass ejection produced by a flare similar to what was witnessed by Carrington way back in 1859 could blow out transformers in the power grid or even cause high-frequency radio signals to become completely degraded or absorbed, which will then result in a radio blackout. The operators of the telegraphs reported receiving several electric shocks. During the evenings, northern lights appeared as far south as Colombia, which is almost near the Earth's equator. Usually, these lights are only visible at higher latitudes in northern Canada, Scandinavia, and Siberia. The entire event today is known as the Carrington event, and this is by far one of the most massive geomagnetic storms we have ever recorded. These storms usually occur when the surface of the sun ejects a large bubble of superheated gas that's known as plasma, which then hits the Earth. This bubble is known as the coronal mass ejection. The plasma of a coronal mass ejection consists of a cloud of protons and electrons, or electrically charged particles. When these particles reach the Earth, they will be interacting with the magnetic field that surrounds our planet. This interaction causes the Earth's magnetic field to distort and weaken, which results in the strange behavior of the northern lights or aurora borealis and several other natural phenomena. The Carrington event of 1859 might be the largest recorded geomagnetic storm, but the truth is it's not an isolated event. Geomagnetic storms have been recorded ever since the early 19th century, and we already have scientific data from Antarctic ice core samples which shows evidence of an even more massive geomagnetic storm that might have occurred at around 774 CE, which is commonly referred to as the Miyake event. That solar flare is responsible for producing the largest and fastest rise in carbon-14 ever recorded. Geomagnetic storms trigger high amounts of cosmic rays in Earth's upper atmosphere, which will then produce carbon-14, which happens to be a radioactive isotope of carbon. A geomagnetic storm that is 60% smaller than the Miyake event occurred at around 993 CE. We have evidence from the ice core samples that showed us large-scale geomagnetic storms with similar intensities as Miyake and Carrington events, and you can expect these at an average rate of once every 500 years. We already have the National Oceanic and Atmospheric Administration that uses geomagnetic storm scales to measure the strength of these solar eruptions. If we were to witness a geomagnetic storm that has got the same intensity as the Carrington event, the effect of these storms in today's day and age would be far more than what happened to the telegraph wires. So you might be thinking, what exactly is going on, and why does this happen in the first place? Well, geomagnetic storms generate induced current, which flows through the electrical grid. The geomagnetically induced currents, which can be in excess of about 100 amperes, will be flowing into the electrical components connected to the grid, such as transformers, relays, and sensors. 100 amperes is equivalent to the electrical service provided to many households today, and currents this size can cause several internal damages to the components, which would then result in large-scale power outages. To put things into perspective, a geomagnetic storm that is 3 times smaller than the Carrington event that occurred in Quebec, Canada way back in March 1989 resulted in the collapse of the Hydro-Quebec electrical grid. During the storm, the high magnetically induced currents damaged the transformer in New Jersey and tripped the grid's circuit breakers. The outage left 5 million people without power for about 9 hours. Keep in mind that this storm was actually 3 times smaller than the Carrington event, which means we need to pay serious attention to the geomagnetic storms. If you think the bad news ends there, well, that is not the case, because in addition to electrical failures, a massive solar storm will also disrupt several communication systems on a work across the globe. The internet service providers will be down, which means you won't even be able to watch this video if that happens. This means that the world will have to prepare alternate communications methods which are not yet developed, because our focus is fully on improving the existing systems that are vulnerable to geomagnetic storms. Other disruptions include high-frequency communication systems, such as ground-to-air, shortwave, and ship-to-shore radio. The currents from geomagnetic storms will also burn circuit boards, which could damage satellites in orbit around the Earth. This will lead to disruptions in satellite-based cell phones, satellite internet, radio, and even television. We are completely dependent on electricity and some of the cutting-edge communication technologies. So any disruption to the existing communication systems could lead to trillions of dollars in monetary loss, and it could also risk lives that are dependent on these systems. Once a geomagnetic storm hits the Earth, the increase in solar activity would cause the atmosphere to expand outward. This expansion might change the density of the atmosphere where satellites are orbiting. The higher density atmosphere will create drag on the satellite, which will slow it down, and if the engineers are not able to maneuver the satellites to a higher orbit, they can fall back to Earth. And finally, we'll have to deal with the disruptions in navigation systems, because almost every mode of transportation, from cars to airplanes, use GPS for navigation and tracking. We even have GPS in all of our handheld devices, like smartphones and tracking tags. All of these rely on GPS signals that are sent from satellites. Military systems are also heavily dependent on GPS. Several military detection systems, such as over-the-horizon radar and submarine detection systems, will be completely disrupted, and safety would be at stake. The state of the internet is no different. A geomagnetic storm similar to the scale of the Carrington event could produce geomagnetically induced current in submarine and terrestrial cables, which happens to be the backbone of the internet and data centers that store and process everything from your emails, text messages, scientific datasets, and artificial intelligence tools. All of this means that our communication systems will be compromised, and we won't be able to do anything about it, because we were not prepared for anything like this in the first place. In the end, it's just a matter of time before we witness another geomagnetic storm that might hit the Earth, and that's exactly what NASA has been warning us about. Let's say that if we get to experience a Carrington event-sized storm, then it would damage all the electrical and communication systems that we have worldwide, which would also result in outages that might last weeks, if not months. If the storm is the size of the Miyake event, The result would be catastrophic for the entire world, and the outages could last for months. Even with all the space weather warnings that we have from the National Oceanic and Atmospheric Administration, the world will only have a few minutes to a few hours to act quickly. Even then, it might be extremely difficult to deal with something like this. It is crucial to research ways to protect our existing electric systems from the geomagnetic storms. It could be done by installing devices that could shield vulnerable equipment like transformers, or even by developing strategies for adjusting grid loads when solar storms are about to hit. To make things simpler, it's extremely important to work now to minimize the disruptions that might occur if we were to witness another Carrington event.